Welcome to this explainer. Today, we're tearing down the walls and looking straight at the invisible, physical infrastructure that powers, well, literally our entire digital world. Every single time you send an email, stream a movie, or process a multi-million-dollar corporate transaction, you are relying on a massive, highly sensitive physical facility. We call it the mission-critical site. And understanding how it works, how it's structured, and why it sometimes fails is absolutely essential for anyone operating in today's tech-driven landscape.
Here's our roadmap for today. We're going to start with the modern business engine, move into the 5 types of data centers, take a hard look at the true cost of downtime, and wrap up with why do data centers fail.
All right, Section 1, the modern business engine. Okay, let's dive into this and see what actually physically runs the modern enterprise. When you ask someone what drives a modern business, it's so easy to just jump straight to software, right? Cloud architectures, the latest IT apps, but we need to think a layer deeper here. I want you to think about the physical facility layer that supports all of those corporate goals. Because frankly, without the physical environment, that digital environment simply doesn't exist. Data center infrastructure is the literal engine of the enterprise. It provides the physical foundation of those high-performance ICT resources, information and communication technology, that a business absolutely needs to function and hit its goals. Think of a business like a hierarchy. Corporate goals drive your divisions. Divisions execute the processes, and those processes run on IT apps. But every single one of those applications relies on this physical layer. If the facility stops, say the power cuts out or the cooling fails, staff productivity and all those IT applications stop right along with it, literally dead in the water. Moving on to Section 2, 5 types of data centers. Because, as you might guess, these engines aren't all built the same. They come in very different forms to meet some incredibly diverse business needs. Let's look at this ecosystem.
Looking at the market today, there are 5 distinct types of data centers out there. We've got enterprise, colocation, cloud, hyperscale, and edge. Let's break down exactly what makes each one unique, and importantly, who carries the operational burden for each.
We're going to start with the classic traditional model, the enterprise data center. This is a facility owned entirely by a single business to house its own computer systems, storage, and telecom gear. For their day-to-day operations, this is a focal point. It's a highly critical asset. And because it's a solo operation, the business is completely on the hook for everything. They have to ensure redundant backup power, complex environmental cooling, fire suppression, and of course, strict physical security.
Let's move to and see how this builds when organizations decide they want to offload some of that burden. Enter the co-location or colo model. Here, a business just rents space for its servers. The colo provider takes care of the building, the cooling, the power, the security, the whole shebang. But the customer still provides and manages their own servers. Then you step up to the cloud model. Think software, platform, or infrastructure as a service. Here, the traditional on-prem setup is completely gone. The cloud service provider handles the facility, infrastructure, and the computing hardware. They manage the updates and hit those strict service-level agreements, all delivered right over the internet.
Now, what's really interesting about this is the sheer contrast in physical scale we're seeing right now. On one side, you have hyperscale data centers, the ones owned by giants like AWS, Google, or Microsoft. We're talking massive scale. Minimum 5,000 servers, usually millions, linked by ultra-high-speed fiber. Power is allocated in megawatts, and they lease space out in kilowatts. But then, on the total opposite end of the spectrum, we have the edge data center. These give you similar infrastructure, but packed into a tiny footprint. Sometimes it's literally just a secure container dropped as close to the end users as physically possible to minimize latency and deliver lightning-fast services.
Section 3, the true cost of downtime. With all these different facilities powering our lives, what is the actual cost when they suddenly shut down? Let's look at the high-stakes drama of offline infrastructure. To really ground this abstract concept of downtime, let's look at Delta Airlines back in 2016. They had a power loss, and their critical systems failed to switch over to the backups. The fallout? 740 canceled flights. And the estimated financial hit for that single physical infrastructure failure was a staggering $150 million. And it's not always some incredibly complex, systemic failure either. Sometimes it's a completely mundane, almost silly physical mistake. Take British Airways in 2017. A power supply was accidentally switched off. That one human error sparked a global IT crash, grounded their entire fleet, and stranded thousands of passengers during a massively busy UK holiday weekend, just from a switched-off UPS.
Now, while those are the big headline-grabbing examples, research shows the average unplanned data center outage runs about $9,000. But the maximum downtime costs, those can easily soar right past $2.4 million, according to Uptime Institute studies. And because we're relying more on information technology every single day, those costs are only going up year over year.
So the crucial point is how businesses actually quantify this risk. To get the true cost, you'd need an in-depth business impact analysis. But for a quick and dirty estimate, you can just take your annual revenue and divide it by 8,760. That's the total number of hours in a year. That gives you a rough baseline cost of unavailability per hour. But remember, it's just a baseline. It doesn't factor in seasonality. Imagine going down on Black Friday. And it certainly doesn't account for the devastating long-term loss of customer goodwill.
Which brings us to Section 4. Why do data centers fail? This is the vital question. If we're pouring billions into high-tech gear, redundant cooling, and backup generators, why are these mission-critical sites still experiencing catastrophic crashes?
Well, the reality is actually pretty surprising. The biggest causes of downtime aren't sophisticated cyber attacks or dramatic natural disasters like floods and earthquakes. Nope. The vast majority of failures come down to deeply ordinary human errors and basic hardware or system failures, which, if we're being honest, are often just the result of human error in the first place. Let's look at the specific culprits here to drive this home. We've got human error, power quality issues, electromagnetic fields, and environmental conditions like bad temperature or humidity control. And among the technical side of things, power quality is absolutely the single most important factor impacting equipment availability in a data center today.
Let's put the top two offenders side by side. Human error is exactly what it sounds like. Poorly executed work instructions, literally pushing the wrong button, or just flat out missing a blaring alarm. Power quality, though, that's an invisible threat. We're talking poor voltage regulation, high levels of electrical noise, or high ground resistance. And it's so important to realize that just slapping a UPS on it doesn't fix all your power quality issues. A UPS cannot stop disturbances coming through a faulty ground wire, for sure.
And this brilliantly illustrates the core dilemma the industry is wrestling with right now. Data centers are basically giant concrete buildings built to last 15 to 20 years. But it is literally impossible to anticipate what kind of equipment IT vendors will be selling in 5 years, let alone 20. These new blade servers and extreme density racks just devour power and spit out massive heat loads. A facility built a decade ago simply wasn't designed to handle the sheer demands of the hardware being unboxed today.
So that leaves us with this final, incredibly high-stakes question. Is your data center ready for tomorrow's technology? We've seen that these facilities are the physical heartbeat of the enterprise. We've seen how brutally expensive it is when they stop working. And we know that rapidly evolving IT gear is pushing older infrastructure right to the brink. Understanding these mission-critical sites isn't just an IT issue anymore, it's a fundamental business survival skill. Thanks so much for joining me on this explainer, and I really love this changes how you look at the invisible infrastructure powering our world.